Day 345 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 363, max sum of rectangle no larger than K. The difficulty level is hard, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go on and check out the link in the description so you can get you some. Now let's see what the question says. Given an n by n matrix and an integer k, return the max sum of a rectangle in the matrix such that its sum is no larger than k. It is guaranteed that there will be a rectangle with a sum no larger than k. Alright, y'all, that sounds simple enough, but let's go ahead and take a look at these examples just to make sure we are doing this problem correctly. So in example 1, we have the input matrix equals an n by n matrix grid or a 2D array, first row being 1, 0, 1, second row being 0, -2, 3, k equals 2. So first thing I just want to say, it's important to know that each array inside of this whole array, the 2D array, this array and the inside the bigger array represents a row. So this represents row 1 and this represents row 2. So now let's continue. The output is 2. Explanation says because the sum of the blue rectangle 01, -2, and 3 is 2, and 2 is the max number no larger than k, and k equals 2, right? So what we need to do is we have to look at this rectangle as a whole, which is given to us right here. Then within this rectangle, we have to find a rectangle that has a maximum sum no larger than k. It could be equal to k, it just can't be larger than k. So as you can see, if we take this whole rectangle right here and we break it up into this small rectangle or square, but a square counts as a rectangle. So if we break it up into this smaller rectangle right here and we add all the numbers up inside this smaller rectangle, we add 0 plus 1 is 1, plus 1 plus -2 will give us -1, and then -1 plus 3 will give us 2. So the sum of all of these values inside of this rectangle is 2. And since k equals 2, that means this is the largest maximum sum that we can create out of a rectangle that is no larger than 2. So that means 2 is the highest we can go. If we can create a rectangle where all of the values add up to 2, that's great. But just in case we can't, we want to find the max sum. If it was 1, then if the max sum is 1, then so be it. But we want to get as close as 2 as possible, or 2, because k is 2, right? So we want to get as close as k as possible or equal to k. So let's go ahead and take a look at example 3. It's the same principles, but let's go through it just to really make it make sense a little bit more. So in example 3, we have the input matrix equals this 2 n by n matrix or 2D array with the only array being 2, 2, and -1. The output is 3. K equals 3 and the output is 3. The output is 3 because when you add, so remember, just look at it like this is one row. When we add all of these numbers together, 2 plus 2 will give us 4, plus -1 equals 3. And since k equals 3, then our output is 3 because the rectangle that we created is not larger than k. As long as the rectangle we create is not larger than k, then we're good. It can equal k, it can be less than k, but it has to be the maximum value that we can create that's equal to or less than k. So now that we understand the question, y'all, let's get into the fun part, actual solution. And yeah, let's get started. So the first thing we need to do is we need to create a 2D prefix sum array with one extra row and column, which will help us and make it easier for boundary handling. So to do that, we're just going to declare, excuse me, y'all, we're going to come over here. We're going to declare a variable. We'll call it sub sums. Then we'll say colon. It's going to be a 2D array of integers. So square bracket, int. Come outside those square brackets, we're going to say equal. We're going to say dot init, open up the parentheses. It's going to be repeating colon dot init again. Then we're going to open up the parentheses again. We're going to say repeating colon 0 comma count colon matrix square bracket 0. Come outside the square bracket, say dot count. Then we're going to say, plus 1. Then we're going to come outside of this parentheses and we're going to say comma count colon matrix dot count plus 1. Boom, just like that. Now we need to initialize the result as the smallest possible int. So we're just going to come right here and we'll declare a variable called res and we'll set it equal to int dot min. Now we need to compute the 2D prefix sums for the matrix. So in order to do that, we're going to come right here. We'll say for y in 1 dot 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 matrix dot count. Then we're going to open up the brackets. Then we're going to say for x in 1 dot 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 matrix square bracket 0 dot count. Then we're going to open up the brackets. Now we're just going to create our basic prefix sum formula for each cell. So we're going to say sub sums square bracket y square bracket x equals matrix square bracket y minus 1. Come outside of that, we're going to say square bracket x minus 1. Boom. Then we're going to come right here. We're going to say sub sums again, square bracket y square bracket x. Then we're going to say plus equals sub sums square bracket y minus 1. Come outside that and say square bracket x. Then we're going to come down here. We're going to say sub sums square bracket y square bracket x plus equals sub sums square bracket y. Come outside that square bracket and we're going to say square bracket x minus 1. Boom. And so this is going to add the this right here is going to add the sum from the cell above, and this right here is going to add the sum from the cell to the left. And now we need another one, and that's going to subtract the overlapping area. So we're going to say sub sums square bracket y, come outside that square bracket x. Then we're going to say this time, this should be a space right here. This time we're going to say minus equals sub sums square bracket y minus 1. Come outside of that, square bracket x minus 1. Boom. Now we're going to use some brute force to search through all of the sub matrices. So we're going to come right here and we are going to say for y in 0 dot 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 matrix dot count, open up the brackets. Then we're going to say for x in 0, excuse me y'all, for x in 0 dot 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 matrix square bracket 0, come outside the square bracket dot count, open up the brackets. Then we're going to say for g in 0 dot dot less than sign y, open up the brackets. And we're going to say for h in 0 dot dot less than x, open up the brackets. Now we need to calculate the sum of the submatrix from g and h to y minus 1 and x minus 1. So we're going to say let temp equal sub sums square bracket x, square bracket y square bracket x minus, open up the parentheses, sub sums, square bracket y, come outside of that, square bracket h. Then we're going to come over here, we're going to say plus sub sums, square bracket g, square bracket x. Come over here, we're going to say minus sub sums, square bracket g, square bracket h. Now, if the sum is no larger than k, we need to check if it's the best so far. So we're going to come underneath that and we're going to say if temp is less than or equal to k, we're going to open up the brackets. Then we're going to say res equals max, open up the parentheses, res, comma, temp. But we're not done yet because we need to come all the way down here outside of this initial for loop, this for loop, outside of this for loop right here, and we need to return res. Now that should be all she wrote, y'all. Let's run it, give it a run before we submit it. Let's see. Ooh, it's taking a little while here. Okay, we have an error. Incorrect argument, repeating count. Okay, so let's see where we went wrong here. So should be, let me see. Oh, it should be repeating with a T. Now let's run it again, see if it works this time. Let's see, y'all. And it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we submit it. Oh, I never seen that before, but hey, 170 milliseconds beats -% of users. That's a new one on our LeetCode journey, y'all. I never seen this before. I don't know what it means. I'll have to get back to y'all about that. But yeah, y'all, with that being said, I hope y'all learned something today. But before we leave, y'all, don't forget, get one more look at the code. One more look, this is the top half. I know it's a little bit of code today. This is the bottom half. And yeah, with that being said, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.